Let us continue lecture 5. In the previous video of this lecture, we saw linear density and we also solved an example based on linear density. In this video, we will study planar density. So planar density is given by this formula, number of atoms centered on a plane divided by area of the plane. And for calculating planar density, we consider atoms as circles. Okay? So while considering how much area of the item is contained within a plane under consideration, we consider an item as a circle and we look for the area of the circle of a particular item inside or outside that plane under consideration. So for example, a picture is shown here, and if I try to complete this plane, so this is a square plane, so that is the plane under consideration, and this is actually the face of FCC unit cell, and as you can see there are four corner items and one face centered item. So for this particular plane, we want to find out how many number of atoms are centered on the plane, and to calculate that we consider the items as circle and we find out how much area of each circle is inside this square. Okay, so for example, if we take a corner item, then this much area of this circle representing this corner item is inside the square. So I can say that 1/4 of that circle and hence 1/4 of that corner item is inside this square. Similarly, if you consider this corner item, again this quarter circle, 1/4 of the circle or 1/4 of the item is inside that plane, and hence we can say that 1/4 of the circle or 1/4 of that corner item is inside that plane. Same thing for this corner item. So all the corner items have their 1/4 portion, 1/4 area inside that plane. So hence we have to calculate the equivalent number of items by summing all these portions. So 1/4 of all the corner items, and finally this complete face centered item is inside this square. So this one. So to calculate the number of items centered on this plane, we'll have to sum, we have to find out total of this. So 1/4 of each corner item, and there are four corner items, plus one face centered item completely inside the square. So this gives us 2. So for this particular plane, there are two items centered on it, and area of the plane is side squared. Okay. So let us calculate planar density for planes in FCC crystal structure. So we have been asked to find out the planar density of 100 plane in FCC. So for solving problems on linear density and planar density, you must be very good at indexing. Okay, so in problems related to linear density and planar density, directly the direction uh, indices and planar indices are given. So you should be comfortable with indexing. Otherwise, you may make a mistake while calculating number of items or even area of the plane or length of the direction. Okay, so calculate planar density of 100 plane. So if we consider this as, sorry, this as z, uh, this as x, and this as y, then this plane becomes 100 plane, and this is the picture of 100 plane. Okay, so there are again four corner items and one face centered item. So we calculated the number of items centered on the plane, on this plane particularly on the previous slide. So we have to substitute the values. Number of items centered on the plane are 2, but for your reference, I will write once again. So 1/4 of each corner item, which is shaded here, 1/4 of each corner item, and this complete face centered item is inside the 1, and area of the plane is a squared, but we know, so area of the plane is a squared, and we know that a is 2r root 2 for FCC, where capital R is the atomic radius, and hence I will replace a with that formula. So if you take a squared area of the circle, then this becomes 2 square 4 r squared root 2 squared 2. So 4 into 2 is 8. So this in terms of r become 8 r squared. So I will write that over here, 8 r squared. Okay. So this gives us 2 divided by 8 r squared is equals to 1 upon 4 r squared. So we found out Planar density of 100 plane of FCC crystal structure. So the only thing you need here is the radius of the atom. Okay. So if the radius of atom of a particular element is given having FCC crystal structure, then you can find out the Planar density by simply substituting the radius of the atom in this formula. Calculate planar density of 111 plane in FCC. So this is the FCC crystal structure unit cell, and we want to calculate planar density of 111 plane. So now you should be comfortable with indexing, and this is 111 plane of FCC crystal structure, and the atomic arrangement on this plane is shown here in this picture, and you can see that there are 3 corner atoms, so 1 2 3, and 3 face centered items on this plane. So not complete atom, but some portion of them uh, lies inside the 111 plane. So now we want to find out how many total number of items are contained or lie inside this plane. So let us do that. And to calculate the number of items, we regard each item as a circle, and we find out how much sector, how much area of the sector, area of the circle is inside the triangle. Okay. So if you look at all the 3 corner items, uh, this is an equilateral triangle. This is an equilateral triangle, means that the angle is 60 degree. Now 60 degree is also the angle subtended at the center of the circle that represents corner item. Okay. So what I can do is, we know that area of or angle of sector for complete circle is 360 degree. So out of 360 degree, the sector having a 60 degree angle at the center of the circle is inside the triangle. So this becomes 1/6. So 60 upon 360 is 1/6. So that means 1/6 of each corner item is inside the 111 plane. Then for face centered item, yes. So for this face centered item, that face centered item, and this face centered item, the angle subtended is 180 degree. So half this semicircle is inside the 111 plane or this triangle. So 360 out of 360, 180 degree sector is inside the triangle, and this becomes half. So half of each face-centered item is inside the 111 plane. So let us write the equation for the numerator. So 1/6 into 3. So this is for corner item. 1/6 of each corner item, and there are 3 corner items plus half of each face-centered item into there are 3 face-centered items divided by area of the plane. So we can calculate the area of the plane using trigonometry. I will directly write the area in terms of radius, which is 4r square root 3. So this is your task. You should be in a position to calculate the area of that triangle using or in terms of atomic radius, capital R. So 4r square root 3. So this is the area of that triangle. So this becomes this half and 3 by 2. So this becomes 2 divided by 4 r square root 3. So this is 2, 1 divided by 2 r square root 3. So this is the planar density, or this is the expression for the planar density of 111 plane in FCC crystal structure. As an exercise, you have to find out the planar density of 110 plane in FCC crystal structure. So the atomic arrangement in 110 plane in FCC is shown in this picture for your reference. You have to use it and find out the total number of atoms centered on this plane and find out the area of the plane. Finally, in terms of lattice parameter A, the planar density comes out to be root 2 upon A square. So we know that A in terms of R is given as root 2 upon A is 2 R root 2 whole square. So this becomes root 2 upon 8 R squared. Okay. So you should get this as answer. Compute and compare planar density values for 100 and 111 FCC plane for aluminium. The atomic radius of aluminium is given as 0.143 nanometer. So this is 100 plane, as we saw a couple of slides earlier, and that is the atomic arrangement. The formula for planar density on 100 plane was derived as 1 upon 4r square. So all we have to do is to substitute the value of r in the denominator of this formula, and you get the answer to be 1.223 into 10 raised to minus 19 meter squared, or 12.23 nanometer square inverse. Okay, so this is also meter square inverse because r is in denominator. Similarly, this is the atomic arrangement in 111 plane, and we already seen this. This is the formula for planar density on 111 plane, and again substitute the values of r into the denominator of this formula, and you will get the answer as 1.412 into 10 raised to minus 19 meter inverse and 4.12 nanometer inverse. Okay. So these are the values. So if you compare the values, you can see that the planar density for 111 plane is greater than the planar density for 100 plane, and this is quite obvious because if you look at the figure, then the 111 plane is closely packed, or the packing of items along 111 plane is closer as compared to 100 plane. So you can see there is a these are the empty areas on 100 plane. Okay, but the empty areas on 111 plane are very small, so that's why the planar density for 111 plane is higher as compared to the planar density for 100 plane. You can find out planar density for 110 plane of FCC plane for aluminium with, so this is the value of the radius available. and then compare the value for planar density for 110 plane with 100 and 111 plane on this slide.